Good evening, students. Today is the continuation of the previous lecture series, Classification of Signals. So, in the last session, we were discussing about continuous time and discrete time signal and even and odd signal. Continuous time and discrete time signal is the one which is classified based on the time, independent parameter time. So, if the signal continuously varies with respect to time, then it is known as continuous time signal. If the signal is measured or realized only at definite time periods or only at particular instance of time, then it is called as discrete time signal. Right. Okay. So, a sinusoidal signal can be the best example for a continuous time signal, whereas the impulse signal is the example, shifted impulse signal is the example for a discrete time signal. Next is even and odd. Any signal, even if there is a change in the independent variable, it does not affect the nature of the signal, then it is even signal. If there is any change in the independent variable that ultimately affects the magnitude of the signal, then it is called as odd signal. Today's discussion is about periodic and non-periodic signal. What is periodic and non-periodic signal? If the signal repeats at regular time intervals, then it is called as periodic signal. If not, it is non-periodic. So, any signal that obeys the condition for periodicity, that is x of t is equal to x of t plus t is condition for periodicity, then it is called as periodic. The smallest time period t is known as the fundamental period t naught. Fundamental frequency is nothing but f naught is 1 by t naught hertz. From that we can find the angular frequency as 2 by t naught. So, the fundamental time period is calculated with the help of the coefficient of t by having the formula 2 pi f is equal to omega. From that we can find the frequency, and in turn 1 by f is found to be the fundamental time period t naught. Whereas for discrete time signal it is slightly different. X of n is equal to x of n plus n, where if this condition is met, then the given signal x of n is periodic, where minimum value n naught is the fundamental period. Here f naught is equal to 1 by n naught, and same way 2 pi by n is the unit of m designated as dimensionless. The next type of signal is the deterministic and random signal. Deterministic, from the name itself we can understand the signal is certain. That is, even before the signal appears, we can predict the occurrence of the signal. And also, in other words, we can say any signal that can be represented mathematically can be called as deterministic signal. And another one is the random signal. Random, here also, random is nothing but as such it can happen anytime, anywhere. So, random signal is the one which is non-predictable, and the uncertainty is more, and it cannot be predicted before it occurs. The best example for the random signal is the noise. So, this kind of signal, random signal, cannot be represented using mathematical equation. The next one is the energy and power signal. Energy signal, any signal which can be represented mathematically falls under either energy or power. So, any periodic signals can be easily identified as a power signal, and a standard signal is called as an energy signal. So just not by looking after the signal we can't conclude. Any decision has to be taken with the help of a mathematical statement. Therefore, energy can be calculated mathematically with the formula E is equal to minus infinite to plus infinite x square of t dt. Whereas the power is limit t tends to infinite 1 by 2t minus t to plus t x square of t dt. So both energy and power should be non-zero and it should be finite. Only then the energy can be a finite value or a power can be a finite value. The signal is either energy signal or power signal. In the case of discrete time signal, energy is calculated as summation minus infinite to plus infinite x square of n. Similarly, power is P is equal to limit tends to infinite 1 by 2n plus 1 summation n is equal to minus infinite to plus infinite x square of n. Here also for the discrete time signal, a signal is said to be energy signal or a power signal only if it is greater than 0 or less than infinite and it holds the finite value. So hope you understood the major classification of signals and systems. Thank you for listening. Thank you.